All right, one thing I want to point out, I meant to say this on the last slide, but whenever you have greatest common factor, or the one thing about the greatest common factor is check for it every time. So like even if you have these other versions, always check for a greatest common factor first, right? So that's the first thing you want to check for. So always start by checking for GCF, okay? And there's actually one other thing we'll do first, but start by checking for GCF, and then you can do the other types of factoring, okay? All right. Okay, so the first thing we want to do actually, before we do all that, notice how all these are set equal to 0. So that's the first thing we're going to do, is we're going to set one side equal to 0. And we're going to do that just by moving, you know, everything to one side or the other. Okay, and we'll see that when we get to the examples. So number 1, that's already done for us, right? We have one side equal to 0. So now I can see, okay, this is a situation where C is equal to 0. And so I'm going to use the GCF method, right? I want to look for, is there a common factor between x squared and 9x? And there sure is, right? It's x. So I'm going to factor out an x, and then I'm going to put my leftovers back inside, right? Just like after you eat, you put your leftovers back inside the fridge. So that's what we do when we factor out a GCF, right? Is we put our leftovers back inside the parentheses there, or back inside the fridge, if you will. All right. Now, the way I got those, in case you forgot, once you find the GCF, you divide each term by the GCF, right? And that's how you get these numbers on the inside, right? X squared divided by x is just x, right? And 9x divided, or negative 9x divided by x is just negative 9, okay? So if we were to distribute, we would get back to what we started with, right? So that's how GCF factoring works. All right, now the reason this is beneficial is because now I have two things that I'm multiplying together get 0. So the 0 factor property comes into effect here, right? For this to be true, that means each of these factors have to be equal to 0, right? Or at least one or the other, right? I should put an or in there. So one or the other has to be equal to 0. So this one is already done. I don't have to do any additional solving. It's already done. Here I want to add 9 to both sides, and so we get x equals 9. All right, so those are our two answers, our two solutions to this particular equation. All right, and remember, we call those roots, zeros, solutions, x-intercepts, all those things. All right, let's take a look at number 2. So number 2 here, we don't have one side equal to 0. So what I want to do is I can either subtract 7x squared from both sides, or I can subtract 4x. Generally, you want to keep your x squared term positive. And so since it's positive on the left, I'm going to move everything over there with it to the left. Okay, so I'm going to subtract 4x from both sides, and we'll end up with 7x squared minus 4x equals 0, right? So this side becomes 0. Okay, so now we can do the same thing that we did before, right? So sometimes you have a common factor bigger than 1 here, but 7 and 4 do not have a common factor bigger than 1. So, but we do have an x in common. So I'm going to factor out an x, and then I'm going to divide this by x, and I'll just get 7x. Then I'll divide this by x, and I'll just get negative 4. Then bring down the equals 0. Okay, so now 0 product property. Either this has to be 0, or this has to be 0, right? The only way to multiply to get 0 is if you multiply by 0. So one of these has to be true. Okay, so x equals 0 is one possible solution. Or here, I'm just going to do some algebra. I'm going to add 4 to both sides. So we get 7x equals positive 4. Then I'm just going to divide both sides by 7. And so we get x equals positive 4/7. So that's our other solution, okay? All right, so that's how we do GCF factoring.